Hello everyone. So this part we are going to start the section 2, definite integral. We are going to check the definitions of the area we discussed in the section 1. So now let's go through all those details we discussed. If we are given a function curve, fx, and then how can we find the area of the region S? And we know how we formed the region S, right? How can we get the area of the region S? Now, what did we do? Okay, now let's go through all the details to form the framework. Then we can talk about the definition. So if f is a function defined for on the interval should be, sorry, let me change my pen. So if a function f is defined on the a and b, okay, x is between a and b, then we divided the interval a, b, right? The interval formed is a to b. We divided the interval into n subinterval of equal weights. Now what is the equal weights? How can we find the equal weights? It's delta x we called, right? Delta x we called, then b minus a over n, right? Over n. And then we let the x, all those endpoints, what are those endpoints? So we let x0 equals a, and then we put x1. What is x1? x1 is a plus delta x, right? And x2 is a plus 2 delta x, or x1 plus delta x, like that. And until the last one, xn. What is xn? Xn actually equals to b, right? We mark those endpoints for n subintervals. And what is the sample point? What is the sample point notation? So in each subinterval, we have the sample point notation star, x1 star, x2 star, xi star, until the xn star. So this is sample star is just a notation, okay? Notation, not specific values. This star means you can, for example, xi star, that can be any value, okay? xi star can be any values in the I interval, I subinterval, and including the left endpoint and the right endpoint. So of course, like this one, xi star, it's a notation, okay? It can be any values we choose in the I subinterval. What is I subinterval? Xi minus 1 to xi, right? So why we form all those framework? What shall we do here? We divided into n strips. We count the subinterval. We choose the sample point, because we are going to define the area of the function f under the f from a to b. How can we find the area, right? So we form those framework. Then the definite integral of the function f from a to b is represented in this notation with a stretched letter s kind of symbol. We call the integral sign from a to b, fx dx. What does this mean? This is the limit. This is the limit of this sigma notation. What does this sigma notation mean? That is the part we talk about in the section 1, which means when the index I can go starting from 1 to n. So my I can be 1 to n. So fx1 star times x. What is fx1 star times x? Of course, that is the rectangle. First rectangle's area. And then x2 star times delta x, second rectangle's area, until, that means if we span until the last one, fxn star times delta x. The part I wrote just means we expanded the sigma notation. I guess we saw the sigma notation last semester, and most people understand what is this one if we expand it, right? So that again is the limit as n goes to infinity, which means we increase the number of rectangles. We get the infinite number of rectangles, then we count the sum of the areas for all the rectangles, right? So we can define this one. Actually, we know it's area A, right? Again, what is the area A? The area A is the area for the region S, right? The region S. Think about the scenario. The sigma again. Can you explain sigma notation again? I already said the sigma notation. Okay, we can repeat it a little bit later. So this limit part actually is the area A. So that means we can define the area A as a definite integral with those notation. And of course, provided the limit exists, okay? And we see that f is integrable on AB, on the closed interval AB. So this is a way. If we can work out this area A, that means we can find the value for, we can evaluate this definite integral. That means f, we call the f is integrable on closed interval AB. Now, let's make some note of this notation, okay? So what does this definite integral expression mean? Let's check one by one, okay? First, the symbol stretched S notation. This symbol was introduced by Leibniz. Okay, Leibniz is famous, and Newton, right? Those two are famous mathematicians in the calculus, and is called an integral sign. So this one is called the integral sign. And what is A and B? They are interval endpoint, right? So A is called the lower limit, smaller value, lower limit of integration. B is upper limit of integration. What does fx mean? Fx means integrand, okay? Integrand, which means we are interested the area of the under the function curve fx. Dx here is just a term, okay? It's just a term to indicate we use the x as a variable, okay? So this is a function about fx. So if you write the symbol just as a to b fx without this term, then it's wrong, okay? This is the notation, okay? This is the notation dx. We will explain later why we should write this part. So the whole thing, how can we read the whole thing? This definite integral. It's called the integral of f, integral of the function f from a to b. Okay. Then when we find the value, what does this value mean? Actually, this value, this notation, this definite integral represents the area A, right? If we can find the value, that means you evaluated the integral. You evaluated this integral, okay? If you are not familiar with this definite integral part, try to take some notes, okay? Try to take some notes. So, according to our definition, again, I just repeat here, okay? I just repeat here. So the definite integral, again, it's a limit. It's a limit of this sigma notation, right? The sum of n approximating areas choosing the sample point, right? Choosing the sample point in each subinterval. So finally, we understand this notation from A to B, fx dx. Don't forget you have dx term. This is the area. Of course, it's a number, right? This is not a function again. This is a number because this represents the area A. It's a number. It does not depend on x. It does not depend on x, which means you can free choose any notation for the independent variable x. So it doesn't matter. You write this letter as you write this independent variable using the letter t, using the letter r, or using the letter s. It doesn't matter. Okay, but you should write ftdt, frdr, fsds. Just means the letter means the independent variable. So everyone is clear about this part? If you understand this is just a number, then it's easy. This is not a function again, okay? So that is note 2. Then next, let's explain the notation, the sigma notation again, okay? The sigma notation again. So this one is called the Riemann sum, okay? With the sigma notation, that is called a Riemann sum. Riemann also is a famous mathematician, and there are a lot of theory in mathematics subject about this person, okay? About this person. So what does this sigma notation mean? Okay, some people, if you feel confused, try to listen carefully and take some note, okay? If we have those general sigma notation here, sigma notation k equals 1 to n a k, so that means we have the index k, okay? That means we have the index k can starting from 1 to n, so it can be a1, a2, a3 until an. What does this sigma mean? You take the sum of all those. So this one actually equals a1 because your k can take all the values from 1 to n. That means from 1 to n, 1, 2, 3, 4 until n. If your n is 5, then it's 1, 2, 3, 4, 5. So that means a1 plus a2 plus a3, a4, a5 until the last term, an. That means you take the sum, okay? So that is the summation symbol, and this is called the Greek letter sigma, okay? Sigma. And then the index k can starting from 1 to n, they are integers, okay? ak is the formula. So here, in this term, only the index I appears in the function f, which means when we take the height for each rectangles, actually this is this change, right? The height for each rectangles are different, but the width is always the same. Delta x does not change. So the I only relate to the xi star we choose in the I subinterval. So the height will change, but the rectangle's width does not change. You can think about the graph, right? The graph we're talking about. The width for each rectangle is always delta x. So that's again, we explain what is sigma notation means, okay? Note 3. Now, let's discuss again here. We know this symbol means the area A, right? This is area A. So according to our normal knowledge, if we are talking about area should be a non-negative number. Especially it can be 0, but usually it's always a positive number if we're talking about the area in a general way. Do the area is a variable? I think it's a challenge question. The region is given. We are discussing the area we can work out. So the area should be a number, okay? It's a value. It's a value, okay? It's a value. It's not a function again. So of course it's not a variable, okay? So let's talk about this one. This is again, it's the area formed, those two part and those part is the area formed under the function f from a to b, but we have some part below the x-axis. So this is the region S. Those three parts are the region S we get, okay? That is the region we formed. So this is the case when fx might be negative, okay? Because the general one we just talked about when fx is positive. This is like when fx can be negative sometimes. So a definite integral here, it can be the sum of those three areas. And if I talk about the first 2 plus, the 2 plus area is a1, this part is a2, then this definite integral means a1 minus a2, and it's called the net area, okay? So here is the area. So do area not depend on a and b? Of course it's depend on the a and b. If you change the a and b, that means it's a different one, okay? It's a different one. So it's good to ask some question, but we can talk about later when we work out the area. Then you understand it's a value, but it depends. Of course, it depends on the a and b you choose. It depends on the function you choose, right? but it's not a variable. When you specify those values, when you give in the functions, then it gives a number. Okay, it gives a number. So let's continue here. Okay, let's continue here. So this definite integral is again the area, but here we call it the net area should be A1 minus A2. So if we have the area below the x-axis, we put the sign as negative. And if we have the area above x-axis, we take this part as plus. So we do have the minus area, okay, minus area. So we call it net area, okay, net area. So we are, I think A1 is the, let me double check with my note. And let me check with my note. Here, A1 is the area above the x-axis. We are A1, okay? So I'm also, when I go through those slides, I also have my note with me, okay? My teaching note with me. And again, it's the same for you all. When you watch the slides, when you watch the video, try to take some notes. It will help you understand. And this part will be A2 is the area of the region below x-axis. That is the notation I mean. Okay, so here A1 is the area above x-axis, A2 is the area below. So this symbol for this given function a f from A to B, the definite integral should be A1 minus A2. So in this way, it might be you evaluate this definite integral as an area. It's a negative values. Okay. It can be negative values. We will check the example later. Okay, we will check the example later. Now, let's talk about two series, and we will focus on the second one actually. So here I miss f. If f is a continuous function on closed interval AB, or if f has only a finite number of jump discontinuity, then f is integrable on closed interval AB. That means if we talk about f is integrable on AB, then the definite integral, this notation exists. Okay, exists. So what is the condition f is integrable? F is continuous, and we have already known from chapter 1 in calculus, continuity is a very good property, right? Continuity in the graph of a function, it's easy to tell. There is no jump, there is no hole, there is no break, right? It's all connected everywhere from A to B. That is called continuous. And another one means if f has only a finite number of jump discontinuity, right? We understand what is jump discontinuity in the graph, right? Some jumps, but they said finite number, which means you can count. Maybe 2, maybe 10, you can count how many. It's not in infinite case. So it's not very restrict condition or for the function f. If f is continuous, or if f has finite number of jump discontinuity, f can be integrable on the closed interval AB. We can find this definite integral. It exists, which means we can find. Like we talk about the derivative exists at some values, then we say the function is differentiable at some number a, like that. Okay. So we're not going to exactly prove it, but just understand the theory, the requirement for the function f. Now, let's check the second theory. If f, I miss f again here, if function f is integrable on AB, then this definite integral exists. Then how we evaluate this definite integral, which means how, and also you can interpret this definite integral in the graph. It means the area under the function f from A to B. Okay, with the previous graph, the f can cross the x-axis. It can be some part above the x-axis, and it can be some part below the x-axis. Okay, how can we evaluate this definite integral, or how can we find this area A? Then this limit sum. By the way, here, it's different from our notation in the definition. What is definition? Definition means xi star. What is xi star? Xi star is the sample point we choose in the I subinterval, right? So let me write, what is xi star? Let me repeat, what is the sample point? Xi star is the sample point we choose in the I subinterval, right? In the I subinterval. What is the I subinterval? Xi minus 1 closed, okay? Those are all closed. Xi minus 1 to xi. Now we change the function. This is the height, actually. This is the height for each rectangle. Now we change it into xi. What does this mean? So that means for each rectangle, we choose right endpoint, okay? So this is the theory, okay? This is the theory. So we know xi star is the any value you choose in the I subinterval. So we cannot find those specific value. So this theory tells us if you choose the right endpoint, it's the same. It's the same as xi star. Why? Just intuitively, if you increase the number of rectangle, it doesn't matter you choose left endpoint or right endpoint, okay? Then that means we choose the right endpoint, and we take the height, right endpoint, and we take the height. We took the height for the rectangle when we at the right endpoint, which is fxi. Okay, fxi. So that gives us a formula. Okay, that gives us a formula. Now, what is delta x again? Delta x is the weight for each rectangles, right? The equal weights we divided. So the equal weights will be the formula again. That's why we repeat this notation. Delta x will be b minus a over n. Then how can you find the xi? How can you find those right endpoint? x0 is a. x1, when I is 1, is a plus delta x. What is xi? Xi is a plus I times delta x. And the last one, xn. Xn will be a plus n times delta x, which means b, right? The last endpoint, xn is b. Now, in this way, if we give some finite number, for example, a equals 5, a equals 10, like you evaluated 5 or 10 rectangles area, then we can do that, right? We can do that. So let's see some examples, okay? Let's see some examples trying to understand the definite integral notations. Example 1. Express this limit as n approaches infinity with this sigma notation. Express those steps, those limits inside with some notation as an integral on the interval 0 to pi. Express as the integral. So we are going to express this thing as a to b fx dx. Then what is a and b first? What is a and b here on the closed interval? So what is my a and b? Of course, a is the left endpoint 0. And my b is right endpoint pi, right? The question gives on the interval 0 pi. So that is my ab. Now from here, according to theory 2, they give the fxi expression, right? Here should be the limit and theory 2. Okay, let's repeat theory 2. The integral actually, let me write here. Okay, let me write here. Erase this part. So in theory 2, we can define the integral in this way. This definite integral equals the limit n goes to infinity, sigma notation, the index I starting from 1 to n, fxi, which means we choose right-hand point times delta x, right? So I just repeat those notation again and again. So trying to take some note and get familiar with the definite integral and the sum notation here. So comparing with our general formula with this one, so it should be fx times delta x. Then what is fxi here? What is fxi comparing with the general formula? Think about it for a while. fxi actually is the expression in the parentheses, right? It's the expression in the parentheses, so it should be the function xi cubed plus xi times sine xi, right? So this means if they don't use star, which means they took the right hand point, okay? They choose the right hand point. It doesn't matter, right? It doesn't matter. So that is fxi. Then what is my function fx? What is my function fx? This function is when the independent variable is xi, you got this expression. So when it's x, so the function should be x cubed plus x times sine x, right? It's easy. Now I know my a and b. I know the given closed interval. And then how can you express this one as a definite integral? That equals, according to theory 2, that equals the definite integral from a to b, 0 to pi. What is my function fx? My function fx is x cubed plus x sine x, and don't forget the dx term. Okay, so that is, we just express this one. But how can we evaluate this definite integral? How can we find the value of this one? It will be another topic. Okay, it will be another topic. It's not easy because this function is cubic term involves the trig function, right? It's not easy to do it. We will talk about it later. Okay, we will talk about it later. Now, this is I use my handwriting to explain the example, and also I just wrote some official thing, then you can check like that. Okay, comparing the given limit with the limits in theory 2, then we see that they will be identical if we write the function fx in this way, and the closed interval is from a to b. Then we can express this one as fx dx from 0 to pi, right? Now, if we specify, here is a typo. Sorry, here's a typo. A should be 0. A equals 0. Oh, I should use the eraser. Okay. My handwriting is nice. Okay, thank you. I'm trying to improve that. Then it will be more clear for you to follow and to check my notes. Here, A should be 0, right? A should be 0. So, example 2. Evaluate the Riemann sum. Riemann sum means that sum term notation, okay? For the function fx equals x cubed minus 6, taking the sample point to be right hand point, which means my xi star is the xi, right? Taking the sample point to be the right hand point, xi. And a equals 0, b equals 3. That means the closed interval is from 0 to 3, and my n, what is n? Which means we will choose 6 rectangle, n equals 6, right? Because in that Riemann sum should be I starting from 1 to n. Now I specify my value n is 6, right? Now here it means we are going to evaluate the integral from a to b. I just write from 0 to 3 according to theory 2. So the definite integral from 0 to 3 fx, which is x cubed minus 6x dx, right? Fx dx. and that equals the limit. Okay, that equals the limit. But here we are trying to approximating it. Okay, evaluate it, approximating it using, because we specified and what is my n? My n is 6 from I from 1 to n. N is 6. And actually the original formula should be xi star. Now I took xi times delta x, right? So we are going to use 6 rectangles to estimate the area of this function from 0 to 3. Now, take the right-hand point. Take the right-hand point, okay? Right-hand point. Then we need to expand this Riemann sum. We need to expand this Riemann sum using 6. N is 6, which means 6 rectangles, okay? 6 rectangles, delta x, right? Delta x. So we need to figure out when I is 1, fx1 delta x plus fx2 delta x. Just take the values for the index I from 1 to 6, and until the last one will be fx6 times delta x, right? So 6, those are the rectangles. First rectangle's area, second rectangle's area until the 6. So we are going to take the sum of all those 6 rectangles area, right? Now we need to find what is delta x, what are those x1, x2, x6 mean, and what is the function value, right? We will do a lot of some calculations in this example, okay? Now, what is delta x? What is delta x? Formula. Let's recall the formula. Delta x will be b minus a over n. Now we specify all the value. We use 6. Now it should be 3 minus 0 over n is 6. So my equal weights becomes 0.5, right? My equal weights becomes 0.5. Now, what is x0? We are going to write the end point. We are going to write the end point for all the subinterval. My x0 is a. What is a? A is 0. What is x1? Check the formula. xi equals a plus I times delta x, right? I times delta x. So should be a is 0, x1. x1 is when I is 1. x1 equals a 0 plus 1 times delta x. 0 plus 0.5. Of course, x1 is 0.5. What is x2? x2 just means a plus 2 delta x. A is always 0, so 2 times 0.5, which is 1, right? x2 is 1. Now what is x3? Of course, x3 is 1.5, right? And also you just add 0.5 on the previous one, so should be x3 should be x2 plus 0.5, so you get 1.5. Then what is x4? x4 should be, based on x3, you add the delta x, so which is 2, and then x5. What is x5? 2.5. What is the last one? x6. x6 is 3, and actually x6 equals b, right? My b, because here we have 6, we divided into 6. Here they specify, the question specify n rectangle. We give 6 rectangles, that's why we get all those endpoint, okay, for the 6 sub-intervals. Now we get all those intervals. Now we need to calculate what is fx1. How can we find fx1? fx1 means f.5. What is my function? What is my function? My function is 0.5. Here. X cubed minus 6. So should be 0.5 cubed minus 6 times 0.5. Okay, use your calculator to do all those calculations a little quick. So I get f.5 is minus 2.875. Okay. Now I can show you one more. Okay, one more. What is f1? How can you calculate f1? f1 should be x equals 1, so it's 1 cubed minus 6 times 1. What is f1? Of course, f1 is minus 5, which is easy, right? Now, so on. I'm not going to calculate all those. You can do those by yourself. Okay, I just write all the values. fx2, this is fx2. Now fx3, which is f1.5, fx3 will be minus 5